Betelgeuse has a companion star. Vera Rubin discovered the third interstellar object accidentally. The first evidence of direct collapse supermassive black holes. And in Space Bites Plus, developing plans to help humanity deal with finding an extraterrestrial intelligence. All this and more in this week's Space Bites. Betelgeuse is a variable star, and it has two cycles. One is fairly easily understood. It brightens and dims over the course of several hundred days at a time, and this is the kind of behavior you expect for supergiant stars that are in the end stages of their life. They literally pulse and grow and shrink. It's kind of amazing. But there's this second variability that has puzzled astronomers for a long time. And this variability goes on a 2,110-day cycle. And there are no known reasons why a supergiant star would have that long of a cycle, but one theory that's been floating around is that Betelgeuse has a companion star, something that takes about 5.5 years to go around Betelgeuse, which is actually only a little bigger than Betelgeuse itself. This star would have to be about 80% the mass of the sun. And now astronomers think they have directly imaged this companion star for Betelgeuse. The research was done using the Gemini North telescope, which is in Hawaii, and it is one of the most powerful telescopes on Earth. And at the point of the longest elongation, the point at which the star is the farthest away from Betelgeuse from our perspective, they think they see a hint of this companion star beside it. Now, picking apart binary stars that are this close together is really difficult. And in generally, you have to find them through the changes in brightness by the star over time. Sometimes you're seeing the stars side by side. Sometimes you're seeing them in front of each other. With the resolution of Gemini North, they think they were able to pick it out. It's important to know that this is very provisional. This is not a high sigma detection, just 1.5 sigma, but it takes about 5.5 years for the star to complete an orbit. And so there will be another opportunity in about 2.5 years when it's on the other side of Betelgeuse to confirm. If they can see it then that will increase the certainty that they are seeing this binary star. This smaller star is about 1/20th the mass of Betelgeuse and about 1/1,000,000th the brightness. And yet there it is. And what's interesting is the astronomers propose that actually this companion star could help explain the dimming that we saw back in 2019-2020. That a burst of mass loss collided with a pre-existing tail or a shell trailing behind the companion object, and that could explain the dimming. Now, this companion star is almost certainly spiraling inward into Betelgeuse, and either Betelgeuse is going to go off and that will be a moment, or it's going to cross the Roche limit, get torn up, and be consumed by Betelgeuse, probably within about 10,000 years. And we've got more information on Universe Today with a story written by Evan Goff. I promised you plenty more reporting on Vera Rubin and Comet 3I Atlas. Now with Vera Rubin, we're still waiting for it to go into its actual observation mode. With 3I Atlas, we've got a lot of observations coming from different telescopes, but I didn't think we were going to be able to put these two together this early. 3I Atlas was discovered at the end of June. And in the area where it turns out that Vera Rubin had been doing test imaging in that exact same region about 10 days earlier. And so astronomers went back into the old images captured by Vera Rubin, and what do you know? There it was. And so Vera Rubin had actually found and observed 3I Atlas 10 days before it was officially announced. But because it doesn't have all of the filters, all of the tools designed to surface all of the objects, nobody knew what it was that they were looking at. And that was actually about 2 days before we got that first light back on June 23rd. And even in those early images from Vera Rubin, you can see that it is a very comet-like object. It has a coma with this sort of cloud of gas and dust around the nucleus, that they've seen it actually brightening and growing about 58% since it was first imaged. And this is what I love about Vera Rubin. Like, this gives you a sneak preview of this power of Vera Rubin, that someone will discover something and then they'll say, well, let's rewind the clock. Let's look back a couple of years and see if we can find that image in older pictures taken by Vera Rubin. We will have snapshots of the entire sky for 10 years. And this is just the beginning of Vera Rubin's obsession With 3i, it's expected to take another 100 images of the comet as it moves through our field of view in and out of the solar system. We've got a story about that by Andy Thomaswick. And then we've got even more images of 3i Atlas captured by the Gemini North Telescope again. And in this, you've got these multicolor images that are taken by Gemini. And these are just it taking images in different wavelengths of the infrared and visible. And then we've got a combined image where you can see the object in much better detail. Like I said, Gemini is one of the most powerful telescopes on Earth, and so it is taking some really great pictures. The challenge is that 3i is moving through the dense star field in the Sagittarius constellation, and this is the heart of the Milky Way, and so there's a lot of stars. It's really hard to pick it apart from that, but it's going to move out of that region into better, clearer skies shortly. Right now, it's about 4 astronomical units from the sun, but it's going to get to within 1.4 astronomical units in October 29. And so that's when we'll see the largest possible tail. It should be really interesting. And then after that, in December, it's going to come to its closest point by Earth, but still only about 1.8 astronomical units away from the Earth. The closest view that anybody is going to get is it's going to be passing within 0.2 AU of Mars. And of course, the Mars Reconnaissance Orbiter is there. It's got a pretty good telescope on board, and so it'll be able to take pictures of it. And we've got a story about this by David Dickinson on the site. Pulsars are neutron stars, and you get neutron stars when an object with 8 to 20 times the mass of the sun explodes as a supernova. And so the neutron star is the remnant. And shortly after they form, they have all of the angular momentum of the original star. They're spinning incredibly quickly. They get these magnetic fields and will produce these regular pulses of radio waves. And these are the pulsars, and they can be flashing for hundreds of times a second. But eventually, pulsars slow down, they dissipate a lot of their energy, and they stop producing those regular pulses. They die and just turn into plain old boring neutron stars. But astronomers have found a few rare objects which are giving out pulsar-like flashes, but it's taking them every few minutes. These are called long period radio transits. And now astronomers have found one of these long period radio transits that is spinning up. It's getting faster. Now it has 2 cycles. One is at 841 seconds, and this is way beyond where a pulsar should be dead. But then it has a second cycle at 4,206 seconds, which is exactly 5 times longer than the short cycle. And so what is it? Well, astronomers don't really know. Now they have some theories. It's probably some kind of binary system that you've got a neutron star in orbit around a white dwarf, or maybe there's 2 neutron stars and they are interacting, and that because they are going around each other, the companion star is spinning up one of the objects. Now, it's a really fascinating object, and I had a great interview with the discoverer behind this, and that's going to be coming out on the channel probably on Monday, so stay tuned for that. And we've got a story about this by Matt Williams on Universe Today. Okay. This is huge if it holds up. Like, I think this is going to be the story of the year if it holds up. And what it is that astronomers think they found the first evidence of a direct collapse supermassive black hole. So let me sort of explain what's going on here. One of the really fascinating discoveries made by James Webb is that there are a lot of supermassive black holes early on in the universe. Even within the first 500 million years of the universe, there are these objects that are hundreds of millions of times the mass of the sun. And this is surprising. How could you get these supermassive black holes so quickly? Now, there's 2 main ideas for where you get supermassive black holes. One is the light method, where you've got regular stars forming. They detonate a supernova, they become black holes find each other, they merge together, you get more of them, they accrete material at the same time, and they grow steadily over time. As long as they're in a rich environment with lots of sources of additional mass, they can grow, and you can just get to these possible black holes. The other way is the heavy seed method. And this is where you get a giant cloud of gas and dust just collapsing naturally and forming a supermassive black hole. And then you could have a black hole with any mass, just as long as you have enough material in the area. The problem with that theory is that as material is starting to come together, you get the region heating up, you get these powerful stellar winds that blow away any material, and it sort of prevents the ability for this black hole to get any more massive. So there has to be some kind of turbulence or way that material is being channeled that resists being blown away by these stellar winds. And now astronomers think they found this. And now this is found with James Webb, and it's two galaxies that are in the process of merging, and they're so close together, they look like they form an infinity sign. So they're called the infinity galaxies. But what's interesting is that you've got these two galaxies, and instead of having the supermassive black hole at the centers of either of these two galaxies, you've got this supermassive black hole in this cloud of gas and dust that is in between the two galaxies. And so because you had these two galaxies come together and this very energetic collision between them, you had this gas and dust forced into this area that was close enough that a black hole could naturally form. And if that's the case, then you can imagine there was lots of situations where galaxies were coming together, that you got this material condensed into this one area, and you could get black holes spontaneously forming. And this would explain why we see supermassive black holes. Now, again, this is the first observation of this. We're at the very beginnings of this. But if this is the case, then this would help explain why we see those supermassive black holes so early on in the universe. We've got a story about this by Evan Goff. And speaking of black holes, part of the challenge with these observations from James Webb is you get this survivorship bias, that we see these really massive supermassive black holes because they are active and they are blasting out large amounts of material. And we don't see the fainter objects that are just hanging out and doing their own thing. And so there's a survey done by James Webb called JADES. This is the JWST Advanced Deep Extragalactic Survey. And they are gathering spectra on thousands and thousands of galaxies early on in the universe. And now with enough of these galaxies and with enough of this spectra, they're starting to pick out the evidence of active galactic nuclei for a lot of these galaxies. Now they're finding galaxies that have supermassive black holes with merely 1 million times the mass of the sun, and not these ones with hundreds of millions or billions of times the mass of the sun. And so as you get more and more data from James Webb, it's starting to fill in the missing pieces of the population sizes of these different supermassive black holes. And this is kind of exactly what you would expect over time as we get more and more time on the sky. We first see the outliers, and then we get a much better sense of what that time and space really looks like. And we've got a story about that by Andy Thomaswick. Every week we do a vote on our channel where you tell us what you thought was the best news story of the week. And the winner last week was the possibility that Earth is in a giant void. So thank you everybody who voted last week. Now we're going to put the new vote into the post tab here on our YouTube channel. So if you have a second, just go ahead, go there, see the new poll and vote. Of course, the best way to see these polls is to subscribe to our channel, click on the notifications bell, and then just every time you see a poll, interact with it, and that will train the YouTube algorithm that you want to see more of this. So last week, I talked about an object that is in a resonance with Uranus. And now astronomers have announced they found an object that's in resonance with Neptune, but this one is much weirder. The object is designated 2020 VN40, and it has a 10-to-1 orbital resonance with Neptune. What that means is that it orbits once for every 10 times that Neptune orbits the sun. And so it has a very long orbit that brings it much farther away from the sun than Neptune does. But this orbit appears to be extremely stable, that they've done simulations and it's going to hold this orbital resonance with Neptune for about 30 million years. And in fact, this is something that you see quite a lot, is that you get these orbital resonance for these objects that are on these long elliptical orbits. And one of the big questions is just like, how did you get this process? I've got a story about this from Evan Goff. And as a continuation, one of the theories that astronomers have is that there is this object, Planet 9, that is out there in the outer solar system, and that is perturbing the orbits of various objects and putting them into these resonances, these three-body interactions between Planet 9 and Neptune and so on. But there's a class of objects called sednoids. Sedna is the classic example. This is the one that is currently almost at its closest point to the sun, but then it's going to go out to like 10,000 astronomical units. A couple of other objects have been found with similar orbits, and now one has been found called 2023 KQ-14. And astronomers have nicknamed it Ammonite, which is the fossil cephalopod. And it gets as close as 66 astronomical units and then goes much farther away from the sun. But what's really interesting about this one is that it appears to have been on this orbit for billions and billions of years. And its orbit is a blow against the theory that there is a Planet 9, that if Planet 9 was ever there, it had to cause its orbital interactions early on in the history of the solar system, and then it had to have been ejected. So the mystery deepens. And this story is also by Evan Goff. When a star gets too close to a black hole, it's doomed. That the enormous tidal forces will tear at the star and pull off chunks of the star and then add them to the accretion disk around the star. And after a while, this happens too many times and the star gets completely dissolved and added to the supermassive black hole. And when this process of a star being torn at by a supermassive black hole happens, you get this flash of radiation, which is called a tidal disruption event. And astronomers were watching a supermassive black hole and they detected one of these brightenings. And so this was a tidal disruption event. And then 700 days later, they detected another one of these events. In other words, this star has been orbiting around this supermassive black hole and has gotten too close twice. And so now the astronomers are waiting another 700 days, which should happen in 2026, to hopefully see this happen a third time. If it happens, then it's the same star that's being torn apart, flyby after flyby. If not, then it's two separate stars that are being torn apart, which would also be very interesting. So we've got a story about that by Matt Williams. Time for some pictures. And this time we're going to focus on newly forming planetary systems. Like, we live in this time, which I just can't believe this. We live at this time when we see images of newly forming planetary systems. We see these spiral shapes thanks to the Atacama large millimeter submillimeter array. And they have all kinds of different shapes. You know, some are spirals, some have concentric rings. But astronomers have done follow-on observations using the SPHERE instrument on the Very Large Telescope on one of these newly forming planetary systems. And SPHERE is able to detect the polarized light that is coming from a planet, which is different from the light that's coming from the protoplanetary disk. And astronomers have been able to detect the presence of a newly forming Jupiter-type planet. Probably has twice the mass of Jupiter, orbiting there around this newly forming star. But I just love the picture. And so we've got a story by Evan Goff about that. And then we've got another amazing picture of a newly forming star. This one's about 1,300 light years away, and it was observed by ALMA, again, the Atacama large millimeter submillimeter array. Now, this picture is beautiful, and I really like to see sort of all of the features that are in it. But what's amazing is that ALMA detected the presence of silicon monoxide crystals in this protoplanetary disk. And this is very important. We have meteorites here on Earth that came from the formation of the solar system. Like, everything is 4.54 billion years old. And that some of these meteorites contain these crystals of silicon monoxide. And astronomers know that they can only form when the planetary system was very, very hot. These were some of the first minerals that formed in the solar system. And so now astronomers are seeing these first molecules, these first crystals forming in this other system, which means that we're seeing the moment when these planets are starting to form around this young star. If you want to learn more, we've got a story by Matt Williams. That was a lot of space news, but this is just a fraction of what we're covering at Universe Today this week. For example, how can we detect magnetic fields around exoplanets? Just imagine we detect a planet in the habitable zone of its star, and we detect that it has a magnetosphere. That could tell us that it's a lot more habitable. There's a story by Andy Thomaswick. Engineers have developed a new kind of shape metal, something that can remember its shape even when it's cooled down to the temperature of space. We've got a story by Mark Thompson. And then astronomers spot an unusual magnetic field around a massive young star. We've got a story by Evan Goff. Now, I collect all of the stories that we're covering at Universe Today into my weekly email newsletter, and then I write it, every single word. and then I send it out on Friday. It goes out to 72,000 of my closest friends. It's completely free. There's no ads in it at all. And just go to universetoday.com/newsletter to sign up. Now, we've got a longer version of this exact video, but with one more story. And we call that Space Bites Plus. And that one additional story is going to be pretty cool. I think you're going to like it. And that is that a team of scientists are wondering, how should we be prepared for the discovery of another technological civilization in the universe? Who are the different stakeholders? What are the different technologies that we should be working on today so that if we do make that discovery, we don't lose our collective minds? Now, I'm going to put a link in the show notes so you can go and watch that version of this episode of Space Bites. I'm going to talk about a special deal that we're going to offer you. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Barry Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Balick, Cy Nielsen, David Gilton, and David Matz, Dustin Gable, Evan Pro, Greg Feely, Hudson Ward, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Marcel Smith, Michael Purcell, Modzo, Paul Roebuck, Ren Kaidu, Robeck, Sean Sargent, Stephen Fowler Munley, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. Now, we talk a lot about our Patreon here on the channel, and this is a way for you to support us directly. We are almost entirely supported by our patrons, which means that we're on a fixed income now. However much money we get from the people who support our work is the amount that we can invest in journalism. And most of this money is spent on the journalists who are writing all of these stories. That's the heart of what we do at Universe Today. And then I take those stories, write my newsletter, we pull them together for Space Bites. I pick from the stories that we're working on, and I interview the scientists behind a lot of that work. It's this beautiful system that we've developed, but we're always looking to bring on more patrons who can help us create the best space journalism on the internet today. And for those of you on the fence wondering if it's worth getting involved, there are a bunch of benefits that you can get by joining our Patreon. You can do a personal private interview with me. It's kind of like this YouTube video, except I actually talk to you. Me and my producer Anton will record a patrons only question show every month. It takes about 4 hours and we get through all of the questions. So if you ever wanted your questions answered, then this is the best way to do it. And in fact, we've recorded more than 25 hours of patron only question shows already in 2025. So if you want a lot more content, it's all available. You get all of the overtime content that is the full 2-hour live streams that I do every week, and other really cool behind the scenes content. And so until the end of the summer, we've got a special deal. You can get 57% off your first month joining our Patreon. And that'll give you access to all of that additional material that I mentioned already. We're going to put a link in the show notes. That'll take you to the special offer, and go ahead and sign up to our Patreon and support our journalism. All right, we'll see you next week.